The Northern Lights, otherwise known as Aurora Borealis, are a truly captivating sight to see. I did my best to try and depict it. It's not the best, I'll admit, but the question still stands. What causes the Northern Lights? Hi, my name is Callum, and in this video, I'm going to be talking about the remarkable sequence of events that leads to this visual phenomenon. The first step to the creation of the Northern Lights begins at the center of our solar system, at the sun. Now, the sun is constantly emitting solar wind. What is solar wind? It's pretty much just a ton of charged particles. So, as the sun emits this solar wind, you can see here that it is directly intercepted by Earth's magnetic field. And you can see in this kind of outer layer of the magnetic field, if you will, when the solar wind makes contact, it's pretty much redirected and pushed completely away from the Earth. Now, you may be asking, why does it behave like that? Well, the behavior of a charged particle inside of a magnetic field can be modeled by this equation. F, the force acted on a charged particle, is equal to the charge of the particle times the cross product of the velocity of the particle and the magnetic field. Now, that's kind of, it's a fun equation. I'm not going to get into the usages of it, but involves a bit of your right-hand rule. But bottom line is the magnetic field is solely responsible for deflecting and kind of maneuvering the trajectory of the solar flares. Now, if the solar flares are to get into a lower layer, if you will, of the magnetic field, you can see that if I were to come here, now all those solar flares are directed directly to the North Pole. Remember that solar flares are just charged particles. That's all it is. So that explains why the Northern Lights are only in the North Pole. It's because the Earth's magnetic field simply directs all of that solar wind and radiation directly to the North Pole. But once all that solar wind and radiation is in our upper atmosphere in the North Pole, what actually causes the visual effect, or the colors and whatnot? Well, I'm going to use this red marker to depict the movement of a charged particle. So, when we have this charged particle, which, remember, it has velocity, it's moving, right? When it collides with this oxygen molecule, it releases a sort of greenish hue. And as for the nitrogen, as we have nitrogen moving and the charged particle moving and colliding with the nitrogen, it emits a sort of bluish or purple hue. Well, that's exactly what the Northern Lights look like. It's greenish purple. It's kind of a blend of these cooler colors. And it's a direct result of the collision of charged particles from the sun interacting and making contact with molecules in our upper atmosphere. I really hope this video gave you a deeper appreciation for just how spectacular the Northern Lights really are. And again, if you guys have any questions, I urge you guys to leave them in the comments or look them up yourselves and keep learning.